Hello everyone, good evening and welcome to my channel Aptitude Club. Today we are here to discuss this question on LCM models. Now from the topic LCM we can have very different type of questions, and LCM is one area which can be applied in a lot of areas in quants, but this particular video is specifically on LCM models. So we have four types of models. So I'll take one video each on each of the models. So this is a model where we'll be little bit exploring the concept of negative remainders, and a very easy question once we understand what the model is. Now if you know how to solve this question, I would request all of you to pause at this moment and then try this question yourself first, and then maybe look at the explanation. And if you don't know, then you can continue with the explanation. And if you're new to the channel, do explore the previous videos that I have done on the QA booster playlist. I'll link it in the I section. You can check it out. You'll definitely find it useful in your preparation. So let us begin. Question is saying how many numbers are there in between 0 to 1000, which in the division by 2, 4, 6 and 8 they leave remainders 1, 3, 5 and 7 respectively. So to put it in a simple way, let the number which does this, let the number of such order be n. Let me take it in that way. Let the number of such order be n. That means n is such a number which when divided by 2 will leave a remainder of 1, divided by 4 will leave a remainder of 3, divided by 6 it leaves remainder 5, and divided by 8 leaves remainder 7. So n, let me list it down in this way: divisors and remainders. So divided by 2 it leaves remainder 1, divided by 4 it leaves remainder 3, divided by 6 leaves remainder 5, and divided by 8 it leaves remainder 7. So when you look at this, the divisors are different: 2, 4, 6 and 8. The remainders are also different: 1, 3, 5 and 7. But there's a particular pattern that you can observe here, that the difference between the divisor and remainder in each of the cases, the difference between the divisor and the remainder is 1. Like 2 minus 1 is 1, 4 minus 3 is 1, 6 minus 5, 8 minus 7. The remainder is 1 in each case. Like the difference between divisor and remainder is 1 in each case. And a lot of books you will see that we need to subtract that difference from the number and then solve. But let us understand the reason behind that. Okay, how do we proceed? So we'll keep it at this phase for a while, and then let us explore the concept of remainders a little bit. So basically when I'm dividing, okay, let me explain you the concept of negative remainders. So when I'm dividing something, let us say I'm dividing this 24 is divided by, let us say, 9. So we divide it in this way: 9 to 18 and the remainder is 6. So 2 is the quotient and 6 is the remainder. But this is the positive remainder. Now can I not do this? This can also be mathematically correct, that I'll do 9, 3, 27 and the remainder is minus 3. Mathematically this is also correct, although we don't do it usually, not the conventional way of dividing, but mathematically it's not incorrect, it is correct. So this minus 3 we will call this as the negative remainder. Okay, again here 3 is the quotient. What do you mean by quotient? Now this is a very simple thing, but a lot of times we don't pay attention to these small fundamentals. What is the meaning of quotient? If I ask you that, what do you understand by quotient? Basically quotient is the number of times you can subtract the divisor from the dividend. How many times can I subtract? Because division is continuous subtraction. So how many times can I subtract the divisor from the dividend? So here 2 means I can subtract 9 twice from 24 and I'll be left with 6. 3 means if I go on and subtract it thrice now, so the remainder will be minus 3. And you see there's a beautiful observation that the modular sum of the positive remainder and the negative remainder is equal to the divisor. Modular sum of the positive and negative remainder is equal to the divisor. Let me take another example. Suppose 36 is divided by 11. So 11, 3, 33. The positive remainder is 3. So if divisor is 11, positive remainder is 3, what should be my negative remainder? Think about it for a while. So the negative remainder should be positive remainder minus the divisor, so minus 8. So let us check. 36, if I divide it by 11, 11 4 is 44, so I get minus 8. So how do you get the negative remainder? Now positive remainder minus the divisor is the negative remainder. Okay, this is the concept of negative remainders. What is remainder? I explained what is divisor, what is quotient. Now in the division, this is called as the divisor, the one which divides. This is called as the dividend, the one which gets divided. Quotient is the number of times you can subtract the divisor from the dividend, and remainder is what is left after the division. Now that you have understood what a negative remainder is, let us put that into context in this question. This number n, when divided by 2, the positive remainder is 1. What can be my negative remainder now? How do I get the negative remainder? Let me write it here again. Negative remainder is equal to positive remainder minus the divisor. So remainder is 1, positive remainder, divisor is 2. So the negative remainder in each of the cases, if I write down, you see the negative remainder is minus 1. In this case also it is minus 1, this case also minus 1, this case also minus 1. So I have multiple divisors but the same negative remainder in each of the cases. Okay, so I can rephrase the question in this way, that the number n, when divided by 2, 4, 6 and 8, it leaves remainder of minus 1 in each case. Okay, I hope all of you got an idea till this. It will leave a remainder of minus 1 in each case. Now think about this. Suppose 9, when I am dividing 24 by 9, remainder is 6. That means I can write 24 minus 6, 18 is divisible by 9. If you remove the remainder, whatever is left has to be divisible. 18 is divisible. Similarly, 24 minus 3, 27 is divisible. Basically that means from the dividend, if I subtract the remainder, it should be divisible by the divisor now. So whatever is the remainder, you take it out. So let me rewrite here n when divided by 2, 4, 6 and 8, 2, 4, 6 and 8, the remainder is minus 1 in each case. That means n minus 1. If I remove the remainder, removing means subtracting, and the remainder is minus 1. So n minus 1 will be now divisible, is divisible by 2, 4, 6 and 8. This implies n plus 1 is divisible by 2, 4, 6 and 8. Now what kind of a number is divisible by 2, 4, 6 and 8? Their LCM or any multiple of LCM. So LCM into K. K indicates any multiple of LCM. So what is the LCM of 2, 4, 6 and 8? 2, 4, 6 and 8, the LCM should be 24. Now 24 is divisible by 2, 4, 6 and 8, and not just 24, any multiple of 24 will also be divisible by that. So I can write this is 24k. That means n should be of the form 24k minus 1. 24k minus 1. So next time you see such a question, we usually get such questions, we can develop a model. So the model is this: if I have multiple divisors and I get the same remainder, be it positive or negative. If I have multiple divisors and the same remainder, then the number is k into the LCM of the divisors plus the remainder. Directly we can do this next time without like venturing a lot into negative remainders. This was for your understanding, but now that you have understood, next time you see a question, you can directly reach at this place instantly. K into the LCM of divisors plus the remainder. Here although it looks as minus 1, but because the same remainder is negative in this case, so plus the remainder means plus minus 1. 24k minus 1. That means all numbers in the form 24k minus 1 will leave a remainder of 1, 3, 5 and 7 respectively when divided by 2, 4, 6 and 8. So that part we have figured out, the structure of n. Now the next step is to see how many numbers from 0 till 1000 will be of the form 24k minus 1. So we can solve this in a very easy manner. The 24k minus 1 should be less than equal to 1000. So 24k is less than equal to 1001. That means k is less than equal to 1001 by 24. So k is how much? If you divide this 24 4s are 96 and then 41, 24 1s are 41, 41 24 1 24 16 17 170. So 24 into 7 41 point something. I cannot take 41 point something because everything is integer. So the first value 24k minus 1, the first value is when you put k is equal to 1. So 24 into 1 minus 1, I get 23. This is the first number, and the last number is when I put it as 41. So 24 into 41 minus 1, 24 1 24, carry 2, so 984 minus 1, 983. This is my last number, this is the first number, this is the last number. Hence from k is equal to 1 till 41, for each value of k you will get a value of n. So 41 possible numbers are there. How many numbers are possible? So 41 possible numbers are there, which when divided by 2, 3, 5 and 7, 2, 3, 6 and 8 will leave a remainder 1, 3, 5 and 7 respectively. जो भी 2, 4, 6 and 8, 2 may remainder 1, 4 may remainder 3, 6 may remainder 5, 8 may remainder 7. So concept of negative remainders, very fundamental question. But I hope all of you understood this. What are negative remainders? We don't use negative remainders to conventionally find the answer. It is used to solve questions in remainders. Okay, very simple model, not a difficult question, and I hope all of you understood the explanation of this. So that is it from my end for this video. Thanks for watching and hope you like the explanation. If you have watched it this far, do subscribe to the Aptitude Club channel and explore the previous videos that I've done on this, be it on LRDA or quants. You'll definitely find them useful and insightful. Okay, do feel free to give your suggestions in the comment section, what kind of videos or what kind of topics you want me to discuss, and we'll meet again very soon on yet another video. Till then, keep solving, keep studying, and have a nice day. Bye bye.